Hi, my name is Brian Freestead. I am the leader of the senior design team working on CySat-I. If you are watching this video, it's most likely because you are the EPS subsystem lead. I'm going to take you through this introductory video. We'll go over the file structure of the project in regards to the EPS. We'll talk about some of the recent firmware changes and talk about the next steps that you'll have to take. So the first thing is going to be the file repository, which Dr. Jones should have already shared with you. Now on GitLab we have our root folder here, which is this CubeSat, and if you go inside of here we have two folders, dev and doc. Within doc we have one folder for each of the subsystems, as well as some side folders for other pieces of information about smaller tasks that aren't large enough to be full subsystems. So here we have the EPS, and we have documents here that are related to the EPS. So the most important ones are the user manual, the I2C user manual, and the EPS next steps document. We also have some other less important documents, like the battery cell test report, which has been filed to NanoRacks. We have old documentation, etc. So back, if we go into the dev folder instead, we also have an EPS folder here, and one folder for each of the other subsystems. The EPS folder only contains one thing. It contains this SatPaumon program. This is actually developed by EnduraSat, and it allows you to communicate with the EPS module by plugging in a micro USB cable to your computer and then opening this application. You select the COM port that it's connected to. You're going to want to use 57.6 thousand baud rate, and then you click connect. Now this application is pretty buggy. If you go over to the IO control tab and you do it too late or something like that, it'll just crash. But it does allow you to test I2C functions that you're writing, and a lot of these have already been done. But basically it'll show here what those I2C commands should return in real time, and then you can verify that your function is doing it the correct way. The other important location for software for development of the EPS is in this OBC folder. This is where all of the code that actually runs on the satellite is going to live. We have two projects here. They're both this system workbench project, which there's another tutorial that shows you, walks you through how to set up this development environment. But we have one project for a discovery board and one project for the actual OBC. The discovery board has a very similar chipset as what we've been using to test and emulate the satellite when we need to do it remotely or whatever. So both of those projects are managed here. And within here, the application folder is where all of our custom code is written. It's a little bit different for the discovery board. It's under source rather than application, but and also the way that the libraries work is a little bit different, but it's mostly the same. All right, now I want to talk about some firmware and hardware updates that have been going on with the EPS. Just before spring break of year 2020, we sent in the EPS module minus the battery cells back to EnduraSat, and they are going to replace the actual microcontroller and firmware that is running the EPS module. And this is because we just had lots of questions that were associated with discontinuities in the documentation, and they're just like, just send it in. So we haven't actually gotten back to it since then because of the coronavirus outbreak. We haven't been able to see the new hardware and firmware. However, we do have new documentation that matches it. This revision 2.1 for the user manual is what you're going to be looking for. Also, back in the folder, the I2C user manual revision 2.2 is also the most up-to-date. Older documentation is in here, and it's what the current code is implemented based off of, so that will have to be updated. Alright, now navigating back to the development folder, let's go ahead and take a look at some of this code. So again, for the actual onboard computer, the code lives inside of this application folder, and all of the important code related to the EPS exists within just a handful of files. So there's the EPS .c and EPS.h. Battery capacity.c and h are pretty small. There's not much in there. And then, of course, in main.c, there's some main control loop kind of stuff that exists there regarding the EPS. And there's a little bit that in the helper functions that are utilized by EPS.c. All right. As I said, most of the important code lives within this EPS.c file. So up at the top, I have some descriptions of the file. I have Javadoc style comments for all of the read functions. Some of the write functions are dead simple, so I didn't bother putting anything there. But this will be very important to go over as you're getting started. And I hope the documentation that I've done, it makes it easy enough to get started. There are also a few to-do comments in here. Those won't necessarily be primary tasks, but those are things some of them are primary tasks, but they'll be listed as primary tasks elsewhere, which I'll go to next. So as you're getting started, I'm sure that there's a lot to swallow, and to make it easier, we've put together these next steps documents. So they exist here within the doc/EPS folder, EPS-nextsteps.pdf. If you take a look at this, we have a list of pivotal tasks and a list of stretch goals. This should really help direct your focus for your first semester of the project. And there's no time estimates on any of this, but this is a really good starting place, and some of these will take you a very long time to complete. Alright, so now you have a lot of the information that you should need to get started as EPS subsystem lead. Just remember to read through these user manuals and the EPS Next Steps document, and you should be well on your way. I hope this has been helpful. If you need to contact me, my information is available within the repository. I hope it goes well.